Hey guys, so I'm going to be going over the odds of the test 6.1 review, and then your test will be tomorrow. So the bulk of this test is over rationals. So we've got rational expressions, we've got simplifying, adding, subtracting, solving rational equations, and then graphing rational functions. So if you don't like fractions, just make sure you study up a little bit more than you would want to, just because this test is entirely over fractions. So on the first section, we're just simplifying and then stating the excluded values. So remember that excluded values are whatever makes the denominator equal 0. So whatever value makes the denominator equal 0, that's going to be an excluded value. So on this first one, we're going to simplify by factoring. P plus 9 cannot be factored any further, but 3p plus 27, I can factor out a 3 from each of those, which leaves me with p plus 9. Now I've got p plus 9 on top and on bottom, which would give me 1 over 3. So when I simplify, I get 1/3. Now, it'd be easy for us to see that we get 1/3 and say, well, there's no excluded values because nothing will make 3 equal 0. But we got to remember that we take the excluded values from before it's simplified. So we're going to take 3p plus 27 and set that equal to 0 and see what we get. So we'll subtract 27. We get 3p equals negative 27. And we'll divide by 3. And p equals negative 9. So our excluded value, the value we can never use, is going to be negative 9. Then on number 3, we've got quite a bit of factoring to do here. We have 25v cubed plus 30v squared minus 40v on top. So I see that they're all divisible by 5, and also they all have a v on them. So I'm going to take out a 5v from each. And I'm left with 5v squared plus 6v minus 8. And then on the denominator, I have 35v squared minus 20v. So I'm going to take out a v, because I see that they have a v in common, and I'm also going to take out a 5. So then I see that there's a 5v on top and on bottom, so I'm already going to cancel that out. And I'm going to factor the top further, which is 5v minus 4 and v plus 2. And so we see that nothing is factoring anymore, so there's nothing that is canceling out anymore. So when we're finding our excluded values, remember we're using the unsimplified version, so we're going to be using these for excluded. So we've got 5v equals 0, which just means v cannot equal 0, and 7v minus 4 equals 0, which 7v equals 4, v equals 4/7. So our excluded values are 0 and 4/7. Oops. Now on the next section, we're simplifying, but now we have addition and subtraction in there, and it's not just one single fraction. So what we want to do is get it to be one single fraction. When we are working with addition and subtraction, we do have to make sure that they have a common denominator first. So on this first one, we're first going to factor the denominator so I can see what I'm working with. I've got 3p that I can take out of there, which will leave me with p minus 4. So in order to make the denominators common, I need to multiply the right side by all of that. So I'm going to multiply by p times p minus 4 over itself, so that I'm multiplying by something that's equivalent to 1. The 6p minus 1 will stay the same, and 3p p minus 4 will stay the same, plus, then we've got 3p times p, which is 3p squared, times p minus 4, and then on the bottom we've got 3 times p, so 3p and p minus 4. So then I will combine further and distribute. So this one I'll keep the same. I'll multiply it back out. And 3p squared times p minus 4 would give me 3p cubed minus 12p squared. And then on the bottom, 3p times p is 3p squared times negative 4 is minus 12p. So we see that they have a common denominator now, so I can move to make it a single fraction. This is 6p minus 1 plus 3p cubed minus 12p squared. Combine any like terms that I can. I've got 3p cubed minus 12p squared plus 6p minus 1 over 3p squared minus 12p. So then from there I would want to factor and see if anything will cancel out. The numerator is not factorable, which means that nothing would be able to cancel. So then I would leave my answer as one single fraction like that. Next one we'll do is number 7. Write in a different color. On number 7, we've got minus this time. And again, we need to make a common denominator. So on number 7, we've got n minus 1 over 2 times n plus 1 minus 5n over 3. So on this one, their denominators aren't even close to each other. They have nothing in common. So whenever that happens, what we're going to do is multiply by the opposite denominator. So on this side, we're going to multiply by 3 over 3. And on this side, we're going to multiply by 2n plus 2 over 2n plus 2. So now we've got 3n minus 3 over 3 times 2n plus 2. On the right side, we've got 5n times 2n, which is 10n squared, 5n times 2, which is 10n, and 3 times 2n plus 2. So now they have a common denominator. I can subtract on top. So I have 3n minus 3 minus all of 10n squared plus 10n. So I need to make sure that I have subtraction in there all the way across. That's minus 10n squared minus 10n. And then combine any like terms that I can. Negative 10n squared minus 7n minus 3 over 3 times 2n plus 2. And then so y'all would do the ones on the right there. Now on the next problems, we are solving and then checking for extraneous solutions. So extraneous solutions are basically the same thing as excluded values when you're checking. It's whatever makes the denominator equal 0. So if your solution makes one of your denominators equal 0, then it is extraneous. So essentially, if you had an excluded value as a solution, then you would say that is an extraneous solution, we can't use it. So on 9 and 11, it's the same process as what we were just doing, except now we need to solve. So if we need to make a common denominator, then we do need to work with a common denominator. So like on number 9, we have this 5 over n that needs to change to have an n squared. So we'll multiply by n over n, because I know that's going to take me to an n squared on the denominator. So n plus 4 over n squared equals 1 over n squared minus 5n over n squared. Now on the right, they have common denominators. So I have n plus 4 over n squared is equal to 1 minus 5n over n squared. And now I've got a fraction is equal to a fraction, so I can make a proportion. So I've got n plus 4 times n squared is equal to n squared times 1 minus 5n. So that's n cubed plus 4n squared is equal to n squared minus 5n cubed. Move everything to the same side. 6n cubed plus 3n squared equals 0. Factor out of 3n squared, and I get 2n plus 1 is equal to 0. And then I'll take each of those and set it equal to 0 to solve. So 3n squared equals 0 will mean n equals 0. If you want to work that out, you can. Then 2n plus 1 is equal to 0. And is equal to negative 1/2. Now we need to check if any of our solutions plugged in make our denominator 0. So on the first one, n squared, if I plug in a 0, I'm going to have a denominator of 0. So I cannot use this one. So the only solution that I have is n is negative 1/2. Then on number 11, we're going to do this one a different way just so you can see two different ways of working it. So whenever you've got common denominators already with something additional, what I'm going to do is subtract this 5k plus 5 over k from both sides, which will change my problem to 1 equals k minus 1 over k minus 5k plus 5 over k. So then I'm going to make that one single fraction, which is k minus 1 minus 5k plus 5 over k, which is k minus 1 minus 5k minus 5 over k, which is negative 4k minus 6 over k. So now I have something that I can solve. I'll multiply by k on both sides. I get k equals negative 4k minus 6. Move those k's over to the left side. 5k equals negative 6. Divide by 5. And k equals negative 6 over 5. Then we would go back and check, does that make my denominator equal 0? My denominator is k, so no. So that's a solution that we can use. So we're going to use that same method on number 13 since we have common denominators. We don't have to move it this time since they're both on the right side. So we're going to jump straight into making it into a single fraction. So we've got 1 equals 3 plus 3v minus 18 over v minus 3. So what I'm going to do is multiply by v minus 3 to get rid of it on the bottom. So I get v minus 3 equals 3 plus 3v minus 18. I want all my v's on one side, all my numbers on another. So I've got v minus 3 equals 3v minus 15. I just combined the 3 and the negative 18. I'm going to move the v's to the right and the numbers to the left. So I've got negative 3 equals 2v minus 15. Add 15. Negative 3 plus 15. Positive 12 equals 2v divided by 2, and we get 6. Then we want to check, does that make an extraneous solution? If I plug that in here, I would have 6 minus 3, which is not 0, so v equals 6. Now, the next part is one of the last things that we were doing before this test, and it is graphing these rationals. So on the test itself, it's not going to say graph this function because you would have no time to sketch out a graph, and how would we even see that on like a multiple choice test? So on the test, it will say something like, where are the holes? Where are the vertical asymptotes, the horizontal asymptotes, what is the domain, what is the range, things like that. So we do need to know how to graph and how to find all those key attributes. So on number 15, we do have one where we need to create a single fraction, like the ones that we were working with before. So what we're going to do is get a common denominator. And it's going to be x minus 2, so we'll take 3 and multiply by x minus 2 on both the top and the bottom. So we get negative 2 over x minus 2 minus 3x minus 6 over x minus 2. Single fraction, negative 2 minus 3x minus 6 over x minus 2. Distribute. We've got minus 3x, and plus 6 over x minus 2. Negative 3x plus 4 over x minus 2. So then we need to check if anything's going to cancel out top and bottom, but I can't factor on the top, so nothing's going to create a hole. First thing we look for is the x-intercept by taking the numerator, setting it equal to 0, and solving. So we got negative 4 over negative 3 which is positive 4/3. So we're going to need more space, but our x-intercept, this is number 15, not 16, is 4/3 0. Then we'll find our vertical asymptote by taking the denominator of x minus 2, setting it equal to 0 and solving. So x equals 2 is our vertical asymptote. Find our y-intercept by plugging in a 0 where x is. So 0 plus 4 over 0 minus 2. 4 over negative 2 is negative 2. Horizontal asymptote, Bobo-Botten eats DC. It is the same. So when the exponents are the same, we divide their coefficients. We have negative 3 over 1, which is negative 3. And then we sketch out that graph. Domain, everything except where the vertical asymptote is. If there was a hole, we would exclude the x value of the hole as well. Range, everything except where the horizontal asymptote is. And if there was a hole, we would exclude the y value of the hole as well in our range. So that's number 15. If you need extra space, you can write it on another sheet of paper or whatever you need. Then on number 17, I'm going to write in a different color. We have 1 over x minus 1. So on number 17, we don't have anything added onto it, so we just jump straight into finding each part. So the x-intercept, we take the top, set it equal to 0. Can't happen. So whenever that happens, we say there's no x-intercept. So I'm going to write all of that out here. And we'll find the vertical asymptote. We find that by taking the denominator, setting it equal to 0 and solving. So x equals 1, I wrote v. X equals 1 is our vertical asymptote. Then our y-intercept, we'll take the function, plug in a 0 for x. 1 over negative 1 is negative 1. Then our horizontal asymptotes, Bobo-Botten eats DC. We are bigger on bottom, so that's y equals 0. Oops. And then we'll connect. And our domain and range. Domain excludes our vertical asymptote and our x value of any holes. Range excludes our horizontal asymptote and any y value to any holes. So that is it for what I'm going to be working on your review. The remaining ones are for you to turn in on Canvas, and this time they will be taken as grades for the 6 weeks. So just be aware of that make sure we're getting these turned in on time, and that's it. Study up before your exam tomorrow, and then remember that these tests are now on Proctorio, so make sure that your computer is ready to go and you've got it all charged up and all of that. So I'll see you guys next time.